All right, so chapter 4 is on exponential functions, and we'll get into logarithm functions and by 4.3, I think. So this one starts with exponential functions, which is kind of the more basic one, more intuitive. And so an exponential function basically just means we have an x in the exponent. We have the base, which is represented by a. A is always positive, and a is not equal to 1 because if in this case, if a equals 1, we'd have 1 to the x, which is always 1, so that would just be a constant function. And if a is negative, we can't take even square roots of negative numbers and so on. So since we're dealing with real numbers, we're keeping a positive and not equal to 1. So let's look at a couple of graphs. We have f of x is 3 to the x, and we have g of x is 1/3 of the x. We will make a little table here and calculate some values, plot the points, and then we can see what the graphs look like. And so you can see 3 to the x, we have an increasing function. 1/3 to the x, we have a decreasing function coming down. And so this is what the graphs look like. And so we'll make a couple of observances here. First of all, if we notice g of x is 1/3 to the x, so we can rewrite that as 1/3 to the x. 1/3 to the x is the same as 3 to the negative x, and that is the same as f of negative x. And so thinking back to the transformations that we did a couple of chapters ago, this is a reflection around the y-axis. And so whenever you have a reciprocal exponential function, two exponential functions that are reciprocals of each other, they're just reflecting around the x-axis, because you can always write 1/3 to the x as 3 to the negative x. And so that's how that always works out. And you could see them written either way, depending on the problem. Some other things to notice. So let's zoom in a little bit. That's a little bit small. Looking at these exponential functions, the domain of really any exponential function that we're going to see is going to be all real numbers. That's not universally the case. We could come up with some that would have a restricted domain, but for this class, I think pretty much they will always have all real numbers. And then the range could definitely change depending on the function, but for the basic exponential function, it is all the positive numbers. And if you think about it, pick any positive number that you could have for a base, 4 to the x, say, or 1/10 to the x, or whatever number you want to pick here that would be positive and not equal to 1. There's no way to make that negative. So that number is always positive. And there's no way to make it equal 0 either. In this case, as x gets really big, that number will get smaller and smaller and smaller. As you can see with the 1/3, it would do the same thing with 1/10. It gets smaller and smaller, but it never actually gets to 0. And there's no way to make it negative. So what happens is we have a horizontal asymptote at y equals 0. And so all of these, two things you can say about these exponential functions that we're going to look at in this class is the domain is always all real numbers. Actually, I guess 3 things. The domain is all real numbers. The range is never all real numbers. And then there is always a horizontal asymptote. So those 3 things are always true, at least for this class. Again, things could get more complicated if you take a more advanced class, but for pre-calculus, that is going to be the case. All right. And of course, if a is greater than 1, we have this increasing function. If a is between 0 and 1, we have the decreasing function. And then we'll look at some transformations. Transformations all work the same as far as the shifting and the stretching and all of that goes. All right, so this first example, we're going to find the equation of these graphs. And so we have 2 points here. We have 0, 1, and then we have 2, 25. And so that's really all we need. So we know that it is y equals a to the x. we know that when x is 2, y is 25. So really we just need 1 point. Since we're given there's no coefficient up here. So 25 equals a squared. We know that a has to be positive, so that means that a equals 5. And so we have y equals 5 to the x. And that is the first one. Same thing here. So y equals a to the x. And we know that when x is 3, y is 1/8. So 1/8 equals a cubed. And this one is decreasing, so that tells us that this x is going to be, or I'm sorry, a is going to be between 0 and 1. Here this is increasing, so we know that a is going to be greater than 1. So what number raised to the third power is 1/8? That would be 1/2. So a is 1/2, so we have y equals 1/2 to the x. Okay, so I think we'll stop on this one and finish up this section on the next video.